Okay, so part 2 here on. So that's basically how you do the inverse trig. When it comes to the negatives, it's a little bit trickier because now you have to think about going outside of quadrant 1, right? In quadrant 1, all the angles are positive, all the ratios are positive. So well, the angles are positive, but all the ratios are positive. Sometimes we run across ratios that are negative, and we know how to evaluate those too. The good news is for both tangent inverse and sine inverse, or arcsine, arctangent, you can evaluate them like they're, and then just make your answer negative. So for example, tangent inverse of positive 1 is positive pi over 4, and then tangent inverse of negative 1 ends up being negative pi over 4. Likewise here with arcsine of negative 1/2, a positive 1/2 is positive pi over 6, and so then the arcsine of negative 1/2 will give you negative pi over 6. Okay. Now, the one catch here is cosine, arc cosine. When you do the arc cosine of a negative number, and there's no examples here of that, but when you do the arc cosine of a negative number, then of a negative ratio, then you need to look to the quadrant 2 version of the angle. Okay, the quadrant 2 version of that angle. All right. So let's say example that we were doing cosine of, I don't know, root 3 over 2. The arc cosine of root 3 over 2 is 1/2. But if we did the arc cosine of negative root 3 over 2, wait a minute, what am I saying? The arc cosine of root 3 over 2 is pi over 6. The arc cosine of negative root 3 over 2, though, is not negative pi over 6. Okay, so the arc cosine of root 3 over 2 is pi over 6. For negative root 3 over 2, it's not negative pi over 6. That's what it would be if it was tangent right. It would be just opposites, or if it was inverse sine. Okay, but for arc cosine, it's the second quadrant version of pi over 6, so it's the 5 pi over 6. Okay. Why is that? It has to do with the way that the ranges of tangent inverse, arcsine, arc cosine are limited. Okay. If we think about the graphs of cosine, just cosine or just plain sine, we know that they're waves. Same thing with tangent, right? It repeats. It's not a wave, but it repeats. If you were to do the inverses, if you were to graph the inverses, remember that graphing an function is equivalent to reflecting that original function over the line y equals x. That would result in a wave of vertical instead of horizontal, and so it's going to result in something that's not a function. To avoid that, or to kind of fix that situation, we just limit the range of the arc cosine and arcs in the arctangent. So arc cosine's range is from 0 to pi. You must give all your answers from 0 to pi. Arc sine is from negative pi over 2 to pi over 2, and arctangent is also from negative pi over 2 to pi over 2. Okay, so that's the idea, but again, to kind of help summarize, when you're doing inverse tangent or inverse sine of negative ratio, simply evaluate it like it's a positive ratio, and then just make your answer negative. For arc cosine, again, you like it's a positive version, but then you give the quadrant 2 version of the angle, not the negative of it. Okay? And then last but not least, we talk Pythagorean identities, which is just a little thing, that's going to be helpful. It's kind of one of those things where it's like this random thing we're just kind of throwing in. It is helpful, and it will come up. Anytime you basically see, sine squared or cosine squared, or sine squared plus cosine squared, or some other combination of trig functions that are being squared, you want to be on your toes and ooh, maybe I can simplify using Pythagorean identity. Okay. That's kind of the idea, just to help with simplification, use that, and equivalence and stuff. So of course the original Pythagorean identity is sine squared x plus cosine squared x equals 1. And then you can derive the other two by taking turns either dividing both sides by sine squared and resulting in this, or dividing both sides by cosine squared and resulting in this. Okay? And then for 2 and 3, it's simply a manipulation of these three Pythagorean identities to then match the corresponding pieces that you're given there. All right? And I think that's all I have to say about that. Again, if you have any further questions, please to myself or Mr. Goff. Good luck.